Hello, today we will learn analysis of variance. This analysis of variance we are going to learn in three parts. To avoid monotony in learning, first we will learn ANOVA, then we will learn how to make ANOVA table, and then in the third part we will learn how to compare the variables. Columns. In our video number 23, we had two independent samples, class A and class B, class test A and class test B. We compared the means and then we found out whether there is any difference or not. Now, if there are more than two columns, 3 columns, 4 columns, 5 columns, and if you want to compare it, we don't just compare the means. We compare the variances in all the groups and we see whether there is any difference or not, or any one of them is different. I'm going to show you another file which has 4 classes: class A, class B, class C, D, and we have taken their test and these are their marks, and we want to know whether there is any difference in any of them or they are same. Our hypothesis basically is null hypothesis. There is all are same. All are same. A is equal to D is equal, A is equal to B is equal to C is equal to D. All are same. And alternate hypothesis is any one of them is different. Any one of them is different. See, ANOVA does not tell us which one is different, but it simply tells us out of these 4, only one, which one is different. Any one of them is different. Maybe 2 are different. Now, if you want to compare B and C, C and D and A, then we'll have to go to another step that we will learn in the next video. So we are going to have this video number 25. We are going to learn just ANOVA. Video number 2, we are going to learn how to make the ANOVA table. And video 27, we will learn how to compare A and B, B and C and D, whether there is any significant difference among all the pairs. One way ANOVA is very simple. There is only a simple command. I have already started Anaconda, Jupyter editor, and this command is print stats.f one-way sample. Now sample, I have to choose it from our Excel file test. Now, as usual, as in earlier videos, we have learned how to browse the file, check the file, select the file, and then select the columns which we want. We need not do all the 4 columns. We have got 4 columns here, A, B, C, D. We may do it, the ANOVA, with A, B, C, B, C, D, C, D, A. But we will have to select the sample. Now for that purpose, we will have to import tkinter, we will have to import SciPy for stats, we will have to import other files which I am going to write it above this command. I am going to write this above this command. I am just copying it from my last videos, last programs, which I have saved it. I'll just copy it and paste it. See, I have written import tk enter as tk. This will help me to browse the folder. tk pandas as pd. This will help me to read the file. Maths will also help me, but I don't need maths in this program, but I have written it. I don't need seaborn, but I have written it. NumPy, somewhere I will need it. Matplotlib, pyplot, which I don't need in this because I don't want to make any diagram, any chart. But I need SkyPy import stats. I need stats. Then I also need stats model.api as SMM. Now from the stats model.stats multicom import pairwise ducky HSD, which we will need in our next to next. These two I am going to delete it. I don't, because it will take some time. So I am going to import only these files. I'm just going to run it. In the meantime, I have put a hash on this print so that this way it has already imported all the files. There is no problem. Now I am going to write the commands which we have already learned in our last videos. See, this is a series of learning. You'll have to learn from the first video and go on adding the commands. So I'm just going to write win tk. It will open a window tk. Win geometry size is 500, 700, 500, and it will ask the file name. File dialog will ask the file name, which will be stored in fp. Then the windows will be destroyed. Then df pd read xlfp. Pandas will read the xlfp, and it will see columns. Columns are df columns to list, and it will ask you the count all the columns starting from 1, and it will print count value and the length of the columns. It is not required, so but we can keep it here. Now this one, when it counts, then it will ask you, we have created a blank array lista, and it will ask you how many columns you want. Input y separated by commas. You can write it here. Input your choice separated by commas. And it will create the lista into list separated by commas. Lista is a blank array where you are going to add your choices. After adding the choices, whatever columns you have selected, that will be converted into a kind of sample. Let us add those commands. Now these are going to be your new commands for this program. All other commands you have already learned it. You have already practiced it. So these 3-4 commands to create this thing as sample will be the new one. Now I have created another like your earlier up. This one columns. So I am going to create lista. I have got now lista is for all your columns, all your choice, but sample is a new one. This sample is a new array which will count the list. For count value and enumerate list start as 1, which has already we have been started here, but it will now start again. So you don't need to print count and value again. Simply say there is another array. Simply say there is another array. What that array is, simply number is d. D is equal to df columns, your input value, whatever values you have put it up, -1. So whatever your choices are there, it is going to enumerate and put it into the sample by appending d. We have created d, and then when it goes to the next one, it will be d plus 1. So as many as whatever you have got it, So it will work on. For count value in enumerate. Same thing for count value in enumerate, column start is equal to 1. So now the same thing which is lista is there, I am going to convert into sample. So this D will be your input value and D will be D plus 1, then sample append D, sample dot append D. D will be appended as many times as you go on entering it. And now we have got the final one, print statistic. Print F1 way ANOVA of the samples. Now if you don't want, you want to see the sample, you can see the sample. Let us see let us see the sample. Let us see sample. Run. It has opened the file down. I am going to take it now, my test number, file number, which I had taken it as test number 9. No, it is test number 9 is 1, 2, 3. You can take it as test number 10, but I will take it as here test number 9, which is on which the file which I have not shown you, but that file is there 2, 3, I'm going to take up all the 3 columns. So this is my sample. This is my sample. Let us see the file number 10 which I have shown you. The file number 10 which I have shown you of class test. So now this is class test A, class test B, class test C, class test D. So I am going to choose the 2 number 3, 4, 5, all separated by 2, 3, 4, 5. And it will show me the samples. Now the samples are 0. It's starting from 0. Indexing starts from 0. So 21, 23, this is number 2 class A. This is your class A, class B, and then class B, C, and then class D. See, these all numbers are there, class D. Now they have been put into this. Now samples are ready, and I am just going to now print my one-way ANOVA test, which is nothing but F test. So I am going to choose this file, test number 10. So I'm just going to say 2, 3, 4, 5, enter. Now F test is already there. Now statistics is 8.15570 and p-value is C, E minus 0.5. What does it mean? It means you will have to put 4 zeros before 5. Then before that decimal. So it is decimal 0.0000566 like this. Because it has written in this way so that you have to see it 0.000. It is less than 0.01. That means any one of them is different. We can just simply improve it as up to 3 decimals as we have written it in the last session. I'm just going to put the command so that my decimals should be reduced up to 3. I have written the command T statistics is 6.3f. 6.3f means 6.3f. See, there should be 6 digits but 3 should be decimals. P-value also should be 6 and then decimal and then 3 places decimal. And then percentage. This all commands I have written it, T statistics, P-value, everything within the range of percent. Let us see now what happens now. I am going to see it. Test 10. Two, 3, 4, 5, because we have already written it. Everything should be put in commas. So Now it is up to 3 decimal. It is 8.156 T statistics. That is F. This T statistics is basically F. And p-value is 0.000, means which is less than 0.01. And we can say our alternate hypothesis, that is accept alternate hypothesis, means any one of them is different, meaning any one of them is different. Sometimes we need ANOVA table with sum of squares, degree of freedoms, mean sum of squares, and then F value. That we will see in our next video, how to make the ANOVA table. And in our next video, we will compare class test A with class test B with class test C and class test D. Whether there is any, what is the difference, whether there is any statistical difference between the columns. Thanks for watching. We are going to rename this as ANOVA 1. I'm just going to save it, because in my next video I am going to just simply copy these commands and will add one or two commands to learn how to make the ANOVA table. Thank you. You may submit your